Awesome. Hi, everyone. Thank you so much for joining in. I know we've been having a lot many sessions, but I promise this one is going to be equally interesting, if not more.
I hope.
Welcome, everyone who's joining in. Great. Welcome, everyone. My name is Kavya. I'm Director of Product Marketing at TestMu AI, and I'll be your host for this session as part of the fifth edition of TestMu Conference. Good to have you all with us today. Quick ask before we begin. Please post your takeaways on LinkedIn and X, and feel free to tag Prashant and use hashtag TestMuConf so that the rest of the community can follow the conversation along with you. And if you have any questions during or after the session, feel free to drop it in the chat box so that you can, we can basically pick it up if possible towards the end of the session. Great. So let me get started with the topic of today's session. Most of the AI applications that's been built today are quietly tied to something or the other. So it could be a model provider, a runtime, a cloud, a chip, and in fact, all of it. So that's a reasonable trade when you're moving fast and a harder one to unwind, especially if you're 18 months later when the economics or the hardware change. Prashant here works on AI and software at ARM, which is very close to the layer where the portability stops being theoretical. And he is going to help us answer the question which is on the table, that is, what does it actually take to build an AI application once and run it across different environments? And where is that still harder than it sounds? So Prashant, welcome to the session. And everyone, please join me in welcoming Prashant Sharma, who will be speaking on building ones running everywhere, the future of portable AI applications. Prashant, over to you, please.
Thank you so much. Thanks, Kavya, for inviting me again. You have made this mistake twice now, so hopefully, let's see how the session goes. But when we were discussing and debating the topic, in fact, I was conflicted between some of the other options. I thought this is one of those harder problems that has become even harder in the times that we live in because I think distributed computing, at least the last, I would say 10, 15 years, 20 years or so, since AWS till now, with the proliferation of models, it's increasingly difficult where a day doesn't go by. We talk to developers, I talk to developers, and the question is, hey, how do I run it right once and run everywhere? It basically works on my machine and what goes beyond. So I thought maybe it'll be a good conversation. It will be a good idea to have some thinking around what does it mean to be AI native in an application world. What does it? How does it change how you test applications? How do you think about design ethos? Is design even important? And those were some of the things I was thinking about while preparing for this brief presentation. So maybe we can bring up the slides, and these
Yes,
are. Where can I see the?
I'll just bring that
You'll
up
bring
on
it
the
up.
screen.
Okay,
Yeah,
perfect. And then I can control the slides, which is great. So I
absolutely.
think the idea was for me to take sort of the opposite view of presentations. I tried not to go beyond 5 words on every single slide, and then the thinking was let's spend more time discussing, ideating versus getting into definitive answers of what that word would look like. So let's see. Okay, I think I want to start with a phrase that every developer in this room and beyond probably heard at some point in time. It works on my machine. So what? So I think for most of the software history, we have been trying to make the sentence irrelevant, and instead of the sentence going into irrelevancy, we're actually seeing it compounding in the last few years. So we created operating systems, we created abstraction layers, we created virtual machines, created the web, and each generation moved us a little closer to a fairly simple idea that developers should spend time building apps, not worrying about every piece of hardware underneath it. And now I think that the AI is sort of forcing us to solve this problem all over again, except this time it may be really, really harder because AI is rapidly escaping the data center. It's moving onto the laptops, onto our phones, into the browser, into vehicles, into cameras, robots, wearables, industrial systems, and increasingly edge devices. In fact, the next generation of devices would be ambient computing, and it'll look extremely different to what we are used to today in the world that we're living in. And that creates a very fascinating new expectation for developers. Now, as a former developer, not an active or a passive developer that I am today, can I build an intelligent application once and run it everywhere? Not rewrite it, not rebuild the entire software stack, not optimize it manually by 20 different processors, build it once and run it everywhere. And that's the promise of what people call portable AI. And there is a problem. Now, if I'm a developer, I might ask, can my application run everywhere? But if I'm a tester, I have to ask a much harder question. If it runs everywhere, does it still work everywhere? And the distinction is what we're going to sort of touch upon today. And like I said, I probably will not have all the answers, but then the fact is the AI compatibility matrix is exploding. I was speaking with someone in one of the frontier labs, and their job is to make sure their coding assistant app works across all platforms, across all devices, including emerging category. And he was talking to me about a grid. In fact, the visual that you see, sure, is AI generated, but then the metrics is not uncommon. I think that's what many people today, from a compatibility standpoint, do struggle with. So let's imagine we have built a relatively simple AI application. Maybe it's a voice assistant, maybe it's image recognition application, maybe it's a small language model embedded inside a productivity application. So we train the model, we test it, everything looks great. Now we want to deploy it. Where? Well, maybe the cloud, maybe on a Windows laptop, maybe on a Linux box, maybe on an Android phone or browser, embedded device. Or suddenly you would start looking at it as a matrix, and we have different models. So there are a plethora of frameworks. There are runtimes, operating systems, GPUs, CPUs, NPUs, accelerators, um, precision formats, memory constraint. So our model metric starts to look something like model plus times framework times runtimes times operating system times OS times CPU cross GPU, NPU precision devices. That's a pretty intimidating test metrics, if you will. And here is where AI becomes different from traditional application portability. Historically, software portability was largely binary. Does the application run? Yes, no. AI introduces a much more uncontrollable possibility. The application runs, it doesn't crash. The model loads, the inference completes. Now, the projected inference time, instead of 600 tokens a second, drops to 15 tokens a second. So, in a classical sense, the application is running, but then it is not fully optimized for the hardware in terms of experience. So, every functional test it passes, and yet the experience may still be wrong. Another famous or infamous, depending upon who you ask, about this smart smartwatch company talking about its ability to track precision tracking of your route or the map that you may take. Wearing the watch is completely off just because there is a 300 millisecond gap between by the time it picks up a GPS signal to by the time it encodes it on the hardware. So memory consumption doubles, the device starts thermal throttling, optimization changes. Does it run? Is that a binary answer anymore? I don't think so. Does it run with the experience we intended? That's fundamentally a different testing problem, if you will, to solve. So, same model, different machines, different answers. So let's make this even more concrete. So imagine um, I give you roughly exactly the same model. Let's say it's an open weight model. I run it on the cloud on a high performance cluster on an accelerator. Then I run it on a laptop GPU, and then on an NPU, then on a smartphone and an embedded device. Should I expect same results? Conceptually, the answer would be yes, but in practice, things do get a lot more convoluted, if you will. The underlying hardware is different. Available operators may be different. The runtime implementation may be different. The numerical precision, memory behavior would be different. And suddenly, something that looks like a single AI application, like as a monolith, becomes like a multiple execution environment, if you will, which means testing needs to look beyond simple functional correctness, if you will. Now, did the model quality change? Did the latency change? Did the memory consumption change? Can the workload actually sustain its peak performance for an extended period of time? And portability does not necessarily mean identical. So if I'm running a model inside, say, a cloud environment, I might optimize primarily for throughput. But on a laptop, I might care about responsiveness. But on a smartphone, battery life is probably the most important uh, fundamental criteria when you are building and optimizing applications. An embedded memory might just be too tight. Memory is actually tight everywhere as we speak, but then in embedded systems, memory becomes an even more dominant constraint because you don't get the same I/O as you would get on a traditional or a richer compute environment like laptops or smartphones. So perhaps the goal really isn't can AI behave identically everywhere. Perhaps the real goal is can we make AI deliver an acceptable experience everywhere? That means testing needs to understand the context it is broadly operating in. So hardware should almost become boring. And funny that I say that where I come from, I have background from distributed system operating systems databases to silicon architecture, if you will. Now, there is some fairly good news. The the industry in general is building increasingly sophisticated layer of abstraction between applications and the hardware. You know, we talk about the layers, the five layer, if you will, of of compute today, irrespective of whether you're looking at large scale clusters or small scale. You're thinking about this emerging stack at the top. You have the application, then the model, portable runtimes, optimization layers, so on and so forth. And then you have CPU, different IP classes of CPU, GPU, NPU, and specialized accelerators. So that developer ideally shouldn't have to manually orchestrate every single thread on that layer. The runtime compiler ecosystem, as an example, should increasingly determine what model to execute, what precision format, how would the memory be managed, what about leaking, what about workload execution efficiency, and that's exactly what abstraction has done for developers through sort of the computing history. But not because hardware isn't important. It's quite the opposite. Hardware actually has become increasingly sophisticated, but the developer doesn't need to think about it every few minutes. Think about the web. Most web developers don't spend their morning asking CPU instruction executed through their JavaScript. They build just the experience, and the platform handles the complexity underneath. And I think from a portable AI standpoint, hardware abstraction, sort of intelligent compilation, automated optimizations are beginning to make that possible. Now, the more complexity we hide from developers, the more responsibility move into validation, because something still needs to verify all those layers work together, and that's where sort of testing that aspect becomes incredibly important for the supply chain, if you will. So the definition of what is correct has changed significantly. Now, let's think about what traditionally means when we say software is correct. We expect the software an input, we expect a certain output, and we compare the two. it's pass fail. And AI complicates that model significantly. Now imagine you are testing, let's pick an image classifier. Now the cloud version gives you say 94% accuracy. You optimize the model for an edge use case for potentially an edge device. Now let's say it dropped from 94 to 93.3 or 93.8. Did that test pass? Probably. Now imagine it's 91%. Did it pass? Maybe. What if 91%, but inferencing is 4 times faster and uses half the power? Now what? Now this is a there isn't exactly a single answer whether at 91% it's a pass or a fail. We are evaluating a multi-dimensional, I would call it the multi-dimensional quality envelope, if you will. Now, for portable AI, I think that envelope increases, and it should include at least five things: correctness, performance, efficiency, quality, and most importantly, portability. Can we imagine those characteristics across all devices that we care about? Now, the challenge and then that changes the sort of the testing from something that happens at the end of the development into something much closer to a continuous experimentation loop, if you will. So every model optimized becomes an experiment, every hardware targets becomes an experiment, every runtime upgrade becomes an experiment, and every quantization strategy actually becomes an experiment as well. So the question to ask is, did we make the experience better, or did we quietly break something here? And we cannot manually test the matrix. Let's return to this compatibility matrix we talked about. Models, frameworks, runtimes, OSs, CPU, GPU, NPUs, precision format devices, versions. Now multiply these together and the number becomes absurd very quickly. I think I was speaking with someone in one of the premier hardware silicon companies, and they were talking about almost tracking 164 different versions of these parameters that they need to think about. So testing itself has become sort of portable and automated in that way. So imagine a developer commits to a new version of an AI application. Instead of simply running unit tests, the testing system deploys the application across representative hardware targets. It could be a simulated environment, it could be a real environment, it could be a hybrid, it could be a cloud instance, an NPU, smartphone. Pick your device of choice, and then in that sense, automatically it starts to measure accuracy, memory, latency, power, thermal throttling, etc. So your application works across your target environment, or something has changed. Maybe model quality has dropped 2.3% on the target, or latency has increased 40% after the runtime update, or this quantized model meets your accuracy requirements that reduces memory consumption by X percentage. Now, testing isn't simply detecting failures, it's helping developers navigate the trade offs. And I think that's an important evolution, if you will, from the last 5, 10, 15 years of generation to where we are today. The testing infrastructure of the post AI or the AI era simply asks, did it pass? It'll increasingly answer, is this the best version of the application for this target environment? And I think uh, we essentially are now operating a place where AI testing becomes more hardware aware, and then sort of more of an interesting consequence. I think for years, especially in my lifetime as an active developer, much of the software testing has tried to abstract hardware away. I did that. Now AI may force to bring hardware back into the conversation, not necessarily for the application developer, but certainly for the testing infrastructure, if you will. Because two systems running the same model can produce dramatically different user experiences. A benchmark measure on a server may tell you very little about what happens inside a phone, and vice versa. And a 5-minute test may tell you very little about thermal behavior versus running it for 6 hours on battery. So a latency benchmark may hide, memory pressure. So the future of AI optimization of software needs to be hardware aware without forcing every developer to become a hardware expert. Nobody wants to be unless it's a choice, and that's an important distinction. So a developer defines the experience they need. So, for example, a developer may come to you and may ask you, I want the inference under 100 milliseconds, and I want memory below a certain threshold, or power within an acceptable range. And then the testing infrastructure determines whether the experience can be delivered across the target hardware. And in other words, how verifiable it is. Can the platform handle the complexity? And what's the developer specific intent? And I think that's where developer intent is incredibly important. So I think kind of wrapping it up, what build once, run everywhere really means. I don't think it actually means the same binary magically executed identical across all devices on the earth. That's not the point. The point is that it's a wrong mental model, and I think that mental model has to shift, and it is shifting as we see. Instead, I think it's something means far more powerful. I think as an AI developer builds an application around the AI capability, the underlying software stack adapts the capability to an available compute. The runtime decides how to execute it, compiler optimizes it, and the hardware accelerates it, and automated testing continually verifies that the application remains inside the quality envelope that is developer defined, not user defined, but developer defined in this case. And that's also the future I am excited about, because when this works, developers can stop asking which accelerator does the device have versus what experience can I offer to this form factor, to this hardware, to this target user. So I think in closing, I'll leave you with one thought: the future of AI isn't one enormous monolithic model running inside an enormous data center. Intelligence is spreading everywhere into our browser, PCs, cars, cameras, factories, robots, and its devices, into devices we haven't invented yet or currently are under the wraps. So the number of places where AI can execute is going to increase dramatically, but developers cannot become experts in every processor, accelerator, OS, and device, and they shouldn't be. The history of computing is, in many ways, the history of creating abstractions that allow developers to sort of build bigger things without understanding the complexity underneath. And AI is now entering that abstraction layer, if you will. And if we get it right, developers will increasingly be able to build intelligent applications and experiences once, deploy them across an extraordinary, diverse range of compute platforms. And because someone or increasingly something has to continuously verify the experience, still works um, across runtimes device. So build once, run everywhere. And for those of us thinking about quality, reliability, and testing, I think the more important idea is build once, test everywhere, and then run anywhere with confidence. Thank you. Kavya, did I get to the right time? We have about 5 to 6 minutes, I
Absolutely,
guess.
absolutely. Thank you so much, Prashant. And I think that was a very powerful statement with which you ended it. So, yeah, thank you so much for sharing that. I'm going to remove the slide if that's okay,
Sure,
or do you want to
absolutely.
keep it
No, no,
on the
no.
screen?
Please
Perfect.
remove it.
Great. So I can see a couple of questions, and we do have near about 5 minutes. Let me just bring this up on the screen. So the first question is, if an AI agent can make decisions faster than humans can review them, does human in the loop still work at enterprise scale? I think
I,
that's a very interesting question here.
I think yes, for the midterm, yes, because I think a lot of enterprise application decision making is very intuitively embedded in the people who are operating the systems. So, people often ask, hey, when would XYZ enterprise scalable application be wipe coded, if you will? question becomes, it is not just the application and the interwiring and interconnectedness of it, but it is also about the intuitive human knowledge and understanding of how systems work. That is phenomenally important. With agents making decisions far better than humans, absolutely, in a perfect world that will happen. But that dependency and human in the loop is going to start reducing. We can already see a reduction actually. In fact, you look at some of the growth numbers of some of the frontier AI labs. All of their money is coming from enterprises and enterprise users, not just hyperscale consumption and not just token generation from training, but otherwise as well. So we have begun to see that. I For the foreseeable future, I don't see it to get to a place where it's going to replace human completely. I don't think it's happening.
Thank you. It took me a minute to pause that,
Sure.
remove that. Yeah. So the next question is, how would you build an agent that is context and capabilities aware? Would this solve some of the optimization issues across system and devices?
Context aware agent. Would this solve some of the optimization issues? I think, let me answer the second part. Let me try and answer the second part first. Would it solve some of the optimizations across systems and devices? It perhaps can. It
Mm-hmm.
can it can certainly do that in scenarios which are far more predictable, where there is enough historical precedence, if you will, that
Mm-hmm.
you can. In fact, it does that today beautifully. I mean, you can build agents that can essentially simulate optimization issues across devices which are at least two or three or four generations in
Mm-hmm.
production at some scale. How would you build an agent? I think I would sandbox it to begin with emerging use cases, if you will, and see how it behaves, and then start iterating over it. I think that's how actually hardware makers in the mobile space are experimenting with, as they're trying to build different AI experiences for devices, and sometimes in cases for generations that you don't even have the hardware capability. Go back 4, 5, 6 years as an example. An example could be um, a game studio coming to a mobile phone company and asking for, hey, can it be backward compatible to the last 5 generations of your phone? Maybe there is some optimization that's possible. Agents can do that heavy lifting of benchmarking and optimizing it. It doesn't quite solve all the problems, but at least it minimizes.
Thank you, Prashant. I hope that helps the audience understand it better. Now, this is a question that I do keep seeing from time to time, to be honest, and we are having a lot of conversations around it. So, wanted to understand if you have any thoughts about it. So, the question is, if AI continues improving at its current pace, what do you think will fundamentally change in software engineering over the next 5, 10 years? And what should engineers start doing today to prepare for it?
Hmm. We already see some of that systemic change in terms of enablement of mundane software development is no longer required. I think critical thinking is not a skill that will go away. Even as machine becomes smarter as they are, you can. It's one of those questions when people ask, you can speak English, you can speak your German, or you can speak your mother tongue. Then why do people learn languages in college? It's the same way where, yes, software can be written by machines. It is being written by machines. It's getting better by the time. A lot of the software now that I am aware of, production grade software, is also being written by machines, like the regular routines. However, it doesn't take away the human element of, the intuition, decision making that comes with experience. The only way you can prepare for the future is, I would still, somebody asked me this question. Somebody actually I know of through a family friend. They got accepted for a software engineering course, undergrad course, and they're like, "Should we even study?" And I'm like, "Yes, absolutely. I mean, you will need the critical thinking. You will need you will need the systems level thinking that you will get through that discipline and that training. You should think about it. You should do it. Uh, it's going to evolve. You don't have to be hands on keyboard 40 hours a week. I used to be. I have written code continuously for 15 hours, and today I don't. But I still write the critical piece on my own, and then I still let machine do the heavy lifting. At this stage, Heather, your guess is as good as mine. What will happen in 10 years? In 10 years, a lot of things will be. 10 years is too long a time, and even in 5 years, a lot of things will be automated. Will they get to production readiness at an enterprise scale? Will there be the next SAP that will be fully wipe coded? To be seen. That's where the human element comes in.
Great. Thank you so much, Prashant. I think that brings us to the end of the session. Once again, I really appreciate it for being a part of the conference for the second year in a row. And as per usual, right, all your insights have been super insightful, especially for the audience that's listening in. To the audience, please feel free to share the learnings on social media. And yeah, make sure that you connect with Prashant if you have any other questions. And of course, feel free to join the other sessions that are lined up for you folks. Thank you once again, Prashant. Really appreciate this.
Thank you. Thank you so much for having me, Kavya,
Have a
and thank
good
you so
day.
much for listening. Thank you.
See you.
Bye bye. All the best.